All right, Chem 120, problems on Canvas. Remember, check Canvas. I don't know how many times I'm going to have to tell you this, but you need to be on Canvas. All right, so this problem is calculating an empirical formula. Empirical formula is the smallest whole number ratio of atoms that go together. Right? Whole number ratio, keep that in mind as we do this problem. So when we look at this, we have three percentages. The compound has 48.65% carbon, 8.11% hydrogen, and 43.24% oxygen. The interesting thing about this is that if you add all these up, it adds up to 100. And so we can take these as gram percentages as 100. So this becomes 48.65 grams, 8.11 grams, and 43.24 grams for our calculations. So let's start with the carbon. 48.65 grams of carbon. All right? And then 8.11 grams of hydrogen. And the rest, the 43.24 grams, is oxygen. Okay, well, there we go. Now we have some gram weights. But can we compare grams and find out what the ratio is? No, we have to switch to moles. So let's switch to moles of each. 1 mole carbon is 12.01 grams of carbon. Hydrogen, 1 mole of hydrogen over 1.008 grams of hydrogen. Remember, hydrogen is diatomic, but when we're looking at atomic composition, we're not looking at diatomic hydrogen, we're looking at individual hydrogen. The same goes for oxygen. When we calculate the moles of oxygen present in a compound, it's just 1 mole of O, not 1 mole of O2, so we only use the atomic weight to do the calculation. So let's do the math. 48.65 grams of carbon times 1 mole of carbon over 12.01 grams of carbon gives us 4.05 moles of carbon. Next, we do the same process for hydrogen. Hydrogen, not being a gas, remember, it's just the composition of hydrogen, so it's 1 mole over 1.008 grams of hydrogen, which gives us 8.05 moles of hydrogen. Finally, we have oxygen, which also normally appears diatomic, but when we're doing calculations for percent composition, we only use the monoatomic oxygen and its monoatomic weight of 16 grams. That comes out to be 2.703 moles of oxygen. So we have these three numbers, 4.05 moles of carbon, 8.05 moles of hydrogen, and 2.703 moles of oxygen. So how do those relate? Those aren't whole numbers, and they don't go together in that ratio. But what we do is we take the smallest whole number that we have, this one down here, and we divide it into the others to get our ratio. So we'll divide oxygen first because it's the smallest by 2.073, and that gives us 1. We now divide that same number, the smallest one, 2.703, into moles of hydrogen, and that gives us 3. And we do the same thing for carbon. And that gives us 1.5 C. All right, so 1 oxygen, but these aren't whole numbers. That would give us a compound with this formula. But since this 1.5 could be a whole number if we just multiplied it by 2, that'd give us 3 here. But if we multiply 1 by 2, we have to multiply them all by 2. So give us 6 here. And then this one times 2 equals 2. So our actual empirical formula now becomes C3H6O2. Thanks for your attention.